I am Mrs. Sonali Joshi from GH Vaisoni College of Engineering. I am Assistant Professor in Electronics Department. Here I am going to give you information about analog systems and design. See, there are two types of system. One is known as digital system, where we know that there are only two digits, 0 and 1, and the output what we are getting in terms of 0 and 1 only, and the system is 1 0 1 0. But then when I am talking about analog system, these are the continuous systems which are getting me information about continuous signal from 0 to 5 volt, and one more thing, we can go down from 0 to -5 also. So when I am talking about these two systems, here we are going to concentrate on analog systems which are continuous systems ranging from 0 to 5 and once again going down. See, when I am talking about analog systems and design, we are going to obviously design systems using these analog inputs. So when I am talking about the system design, we should understand that there are two types of systems. One is the linear system and another one is the non-linear system. Now, what is linear system? This is the system when output is following the input linearly. It is somewhere that, suppose this is input and this is output. Okay, when input changes and corresponding output also changes, this particular kind of system is known as linear system, wherein with the changes in input, output also changes. These are the type of systems which we are going to study in this analog systems and design. And there is the another system also which is known as non-linear system, wherein with the changes in input, like if I am taking one example, y is equal to x square. What happen here is when the x changes, y also changes, wherein x into x is equals to y. But then there are some equation wherein x changes but then corresponding y, whatever will be the equation, it does not have the linear response at the output. Those are known as the non-linear systems, and both the kind of applications can be designed with the help of operational amplifiers. So we are concentrating in analog systems and design circuits or the system design with the help of operational amplifier. Now what is operational amplifier? The term itself is going to give me information, that is, it is going to perform n number of operation. Like simply when we are talking about operations like addition, subtraction, multiplication, division, and then integration, differentiation, taking filters. So these are the type of systems we can design with the help of operational amplifier. This particular subject is taken care into the 4th semester because you have now knowledge about the transistor, what is IC, and so operational amplifier, which is designed with the help of differential amplifier, we are going to study in this particular semester. Now differential amplifier, we know that when I am taking output which is equal to difference in the input, the circuit is known as differential amplifier, and when this circuit which is giving me difference in the output is designed, the circuit is known as operational amplifier. Now which is going to obviously perform various operations, and the term amplifier obviously gives you information about amplification of the input signal at the output. So these are the applications which is going to design with the help of one IC. This is known as IC 741, and basically we are going to study IC mu A 741, wherein we should understand what is mu A 741 and what is C. Now this mu A stands for the name of manufacturer who is going to who has designed this particular operational amplifier, because there are n number of operational amplifier manufacturers, okay, who has designed this particular operational amplifier. So how come I will know which particular manufacturer has designed this 741? So this particular symbol mu A stands for the manufacturer of 741 IC, wherein mu A is the symbolic name given by the Fairchild company. There are Intel, National Semiconductor, n number of manufacturers who gives their symbolic name before the IC, and then C stands for the we can say it is characteristics of that particular IC which is inbuilt in this 741. Now 741 which was designed by the Fairchild company is available in 8-pin IC, it is available in 14-pin IC, and it is available in 16-pin IC also. So we are going to concentrate our study on 8-pin IC which is available in DIP package also. So when I am talking about any 8-pin IC, okay, so dot at the leftmost side is indicating that the corresponding pin is pin number 1, then will be the pin number 2, 3, pin number 4, 5, next will be the pin number 6, 7 and 8. Okay, so this is the 8-pin IC wherein pin number 2 and pin number 3 are used as the input pins. Out of this, being I know that this particular operational amplifier is designed with the help of differential amplifier. So when I am saying it is differential amplifier, obviously there will be the difference in the input. So to get the difference in the input, we are having two input signals. Out of that, one is known as non-inverting input and another one is known as inverting input. Now why non-inverting and why inverting? Because when we are applying input to the pin number 3, the corresponding output which I am getting at the pin number 6 is non-inverted. It means there will not be phase difference of the signal at the output. When I am giving positive signal, output will be positive. For the negative signal, output will be negative. But when I am giving input to the pin number 2, this is at the output, I am getting 180-degree phase shifted output. That is, for positive input, output will be negative, and for negative input, output will be positive. So the pin number 3 is known as non-inverting input terminal and pin number 2 is known as inverting input terminal. Pin number 6 is used to take the output, and now pin number 7 and pin number 4 are used for supply voltage. To operational amplifier, we are connecting plus VCC, that is in the range of 12 to 18 volt, and minus VEE, both the signals. Okay, so positive and negative, both plus minus VCC or supply voltage we are connecting, so that at the output we will get the fluctuation in both quadrants, positive and negative. Then we are having pin number 1 and pin number 5. These two pins are basically used as offset null pins. Now what is this offset null? See, when we are giving any input to this non-inverting and inverting input signal, without applying any input, when the inputs are grounded, suppose, like we are not providing any input signal, still sometime it may happen that because of some power fluctuation, because of temperature variation, output may have some DC voltage signals in microvolts or millivolts. Okay, so to nullify that DC voltage signal at the output, this pin number 1 and pin number 5 are used as offset null pin. So at the time of designing only, the 10 kilo ohm potentiometer is basically connected between pin number 1 and pin number 5. Wiper of this is connected to plus VCC or minus VEE, depending on whether the error voltage which is generated is positive or negative. If the error voltage is generated as positive, then this wiper is generating more negative output, so that both the signals will get nullified and we will get output without any error signal. So this particular pins are known as offset null pins. And the last is pin number 8, which is of no use. This is not connected anywhere. Okay, so this is basic information about the operational amplifier. Now we know that this is operational amplifier with two terminals. One is the input known as inverting and another as the non-inverting, and the output we are taking at pin number 6. So this is somewhere the symbol used for operational amplifier, and this is known as electrical symbol. Ab output of this particular operational amplifier is given as V0 equals to gain multiplied by difference in the input signal. Now, being I have written it V1 minus V2, you can understand that V1 is the input provided to the non-inverting terminal and V2 is the input connected to the inverting terminal. Why this is so? Because when I am taking the output V1, it has not phase shifted. Okay, V1 I am getting as V1 without any phase shift, and V2 I am getting adds the phase shift with of 180 degree. So this V1 is non-inverting input and V2 is inverting input. Multiplied by gain will be the output. Now this gain term in any operational amplifier ideally should be infinite. Practically its value is 2 into 10 to the power 5. So if I will be talking about this operational amplifier which is having the infinite gain, that is practically 2 into 10 to the power 5 multiplied by V1 minus V2. This particular circuit which is in front of you is known as open loop configuration. In open loop configuration, gain is considered to be 2 into 10 to the power 5. If I consider this particular stage, gain 2 into 10 to the power 5 multiplied by input signal. So to keep the output voltage within a range of amplification. Now how we are going to analyze this circuit? See, this is basically voltage transfer curve wherein this is input VIN and this is output. Okay, so when I am talking about any systems, input changes, so the output gets amplified till the range of plus VCC in the positive quadrant and minus VEE in the negative quadrant. So this is somewhere known as the saturation voltage, if you know. So this is VSAT positive and this is VSAT minus. Okay, so my signals are getting amplified in the range of plus minus VCC, that is plus minus beta sat and only, and then the signals are getting saturated. It means that the output will not amplify. Okay, it will be only till the range of plus minus VCC. So when I am talking about the signals which can amplify only in the range of plus minus VCC, we have given you this particular information that two operational amplifier plus VCC will be in the range of plus 15 volt and minus VEE will be the range of minus 15 volt. Okay, so in open loop configuration, when V0 we are talking is equal to 2 into 10 to the power 5 multiplied by input V1 and V2. This 2 into 10 to the power 5 will be then obviously going to give me output in saturation region, because my supply voltage range is only plus minus 15. So anyhow the output is not going to increase in more than plus minus 15 volt. Okay, so what will happen in the open loop configuration, if I take gain equals to 2 into 10 to the power 5, V1 and V2, that are the input ranges, has to be less than the millivolt or voltage range. So to get proper response, I cannot have the millivolt range because it will be 2 into 10 to the power 5 multiplied by 10 to the power minus 3. Once again it is going to give me output more than plus minus VSAT. So what I need to do is I need to take input in the range of microvolts only. Okay, but then look at this. When I am talking about microvolt range, using the microvolt range practically and generating those range is not feasible and it is not practically possible. Okay, so use of this particular operational amplifier in an open loop configuration is not possible to work this operational amplifier as an amplifier. So what is the next stage then? Obviously when I am talking about operational amplifier, when gain is 2 into 10 to the power 5, we need to now reduce the value of gain. Okay, so that for some range of voltage signal okay, which will be in volts, I should get the amplification. So here, to reduce the value of overall gain, we need to design the circuit using feedback. Okay, now there are two types of feedbacks we know. One is known as positive feedback and another one is known as negative feedback. Now when we are talking about positive feedback, the gain of positive feedback is given by A upon AF, which is equal to A upon 1 minus A beta. Now what is this A? This A is open loop gain and beta is the gain of feedback circuit. So when I am talking about positive feedback, okay, this gives me indication of overall closed loop gain is not as such decreasing than the open loop gain. So we should understand that the positive feedback to be used as amplifier is not as such usable, okay. So there is the another system which is known as negative feedback system, okay. So what is this negative feedback system? Herein part of the output we are taking back as the input to the inverting terminal. This is we are taking with the reference of or using the resistive network, okay. So when I am using negative feedback, the overall closed loop gain is equals to A upon 1 plus A beta, okay. So now the overall open loop gain is decreased by the factor of 1 plus A beta. So I can now concentrate on using the negative feedback, reduce the value of gain, whatever is required for that particular feedback circuit, and then you can use probable ranges of input voltage which will amplify the signal till the range of plus minus Vsat, and the output will not go in the saturation region. So by controlling the factor of beta, which is with the help of RF and R1 network, you can possibly control the gain and generate the output voltage properly. Now this RF by R1 is known as closed loop gain of the amplifier. Now we have two input signal V1 and V2. Using this particular system, that is using negative feedback, we can design three types of amplifier. One, when I am using input to the negative terminal only and the positive terminal is grounded, the overall feedback circuit is known as inverting amplifier, wherein input is provided to inverting terminal and the output is given as V0 equals to RF upon R1 multiplied by input voltage V2, and that too it will be a negative because we have connected input to the negative terminal. So this is known as inverting amplifier, wherein the non-inverting terminal is grounded and input is connected to inverting terminal. Now the second type is connecting only input to the non-inverting terminal by keeping inverting terminal grounded. Now what we are doing is we are giving input to the non-inverting terminal. The amplifier is known as non-inverting amplifier. This time V0, that is output voltage, is equal to 1 plus RF upon R1 multiplied by the input voltage V1. This particular type of non-inverting amplifier is obviously increases the overall gain, and so the output voltage also increases as compared to the inverting amplifier. And the third type of amplifier is known as differential amplifier, wherein we have two inputs, one is V2 and one is V1. So V0 will be equals to RF upon R1 multiplied by, obviously in this case V1 is the input which is connected to non-inverting amplifier and V2 is the input connected to inverting amplifier. So the overall output will be equals to gain RF by R1 multiplied by V1 minus V2. Okay. So what we are doing is we are taking the difference of the inputs at the output. So this is all about what is amplifier and what is inverting and non-inverting amplifier. So we can design this particular circuit or any kind of systems using either inverting amplifier or non-inverting amplifier or the overall differential amplifier. So now we are going to talk about the ideal characteristics of operational amplifier. Now, what are the ideal characteristics of operational amplifier? First and the most important is gain. So, gain of any amplifier should be very much high, so that all the input ranges can be taken care and you will get the proper amplified output signal. Next, we should talk about the input resistance. That is, input resistance should be very much high, so that weak signal should be taken care and you will get the output at the output stage. Next, the output impedance should be very low, that is 0. Okay. So, this is all about the basics of operational amplifier. Now, this is all about basics, and we are going to complete our first session now. After this, we are going to study the different kinds of applications which will be developed or designed with the help of operational amplifier in the next session. So, this is all from my side for today. Next session will be continued with the amplifications technique, then applications of this operational amplifier. Thank you so much.